A certain manufacturing process yields electrical fuses of which in the long run 15% are defective. This is 1.5. Okay. Find the probability that in a sample of 10 fuses selected at random, there will be no defective fuses and at least one defective fuse. Okay. So we are given the long-term data that 15% of the fuses are defective. This means if you randomly pick one fuse from production, the probability that it is defective. Okay, so the probability that it is defective is going to be 0.15. So what is the probability that it is non-defective, or in other words Q, that is going to be 1 minus P, correct? That is 1 minus 0.15 or 0.85. Yes? You are with me? This much is clear. So now what we have to do? We have to find the probability that if we are going to pick a sample, okay, of 10 fuses from the whole lot from the production line, first, that there is not going to be any defective samples, okay, and the second, that at least one is going to be defective. So if, say for example, probability that there are no defective is P of x is equal to 0, then probability that at least one is going to be difficult is defective is probability of x equal to 1 plus probability of x equal to 2 plus like that up to probability of x equal to 10. That is all defective. Or easier way, I can do 1 minus probability of x is equal to 0. That is 1 minus nothing defective. That will also give me at least one defective probability. Correct? So this is basically what the question is asking us to do. So what kind of a problem is this? This is any guesses? I'll give you till the count of 3. Guess and write it in the comments. If you guessed it correct before my counting is up, then maybe a surprise for you. Okay, 1, 2, 3. What is your answer? What is this kind of a question? This is a binomial probability theory or a binomial probability problem. Why? Because we have a fixed number of trials, that is n is equal to 10. 10 fuses were tested and each trial has only two outcomes. Either it is defective or it is non-defective. Is there anything in between? No. Right. So only two outcomes. Bi means two outcomes. Binomial problem. So the probability of a defective fuse is 0.15. This is a constant. The trials are independent. Just because one fuse was failure, one fuse was defective, does it tell anything about the other fuse? No. Each fuse being defective or not defective doesn't affect any other fuse. Correct. Now, so that is why we are saying this is a binomial problem. Now, something that I want you to be aware of as future managers, as future decision makers is beyond academics. These kind of problems will train you to make data driven decisions under uncertainty. If you remember, the first question of this assignment was asking us about the different decision states, and we told that decisions under uncertainty is one such state. So, how do you make decisions under uncertainty? This kind of problems or binomial probability theorem is one of the ways or one of the tools in that decision making toolkit which will help you make data driven decisions under this uncertain situations. It will help you quantify the risks and justify strategies in your organization. These are skills that are essential in quality control, finance, marketing, and even beyond. Hey, if you're enjoying this session, take a quick moment to subscribe to Anu's Classroom and turn on notifications so you will never miss an update. Your likes, shares, and even a super thanks or sticker are little boosts of encouragement that help me keep creating and growing this channel. You got any questions, ideas, or suggestions? Drop them in the comments. I love hearing from you and I'm always here to help however I can. Now let's head back. All right then, let us take our calculators and get clicking. right? I hope you have a pen and a paper and a calculator with you. If you don't have, then quickly take it and come, because I want you to do this thing with me, so that you get that what you can say, the hang of solving such things. So what is the first step? We have to find the probability that there are no defective fuses. That means probability of x is equal to 0, where x is, we are assuming x as the number of defective fuses. Okay, so x is considered as the number of defective fuses. That is why no defective means probability of x is equal to 0. Now what is the binomial formula? Probability of x is equal to r is equal to ncr p raised to r q raised to n minus r. This is the probability formula as per binomial distribution, correct? Yes. So this is what we have to apply. What is n here? N is the number of trials. What is R here? It is the number of success. What is P of R? It is the probability of success. What is Q of R? It is the probability of failure. Now, some cases you will see this formula written like this: NR P raised to R and Q raised to N minus R. Now, NR written like this in in curly braces is nothing but NCR. Okay, so these two are same. If you see such a formula, don't get scared. How do you find NCR? You find NCR as, this is N, okay, not X. This is N. NCR is found as N factorial divided by R factorial into N minus R factorial. Now, how do you find factorial? N factorial? N factorial or X factorial, it is 1 into 2 into, sorry, yeah, 1 into 2 into 3 up to X, or that N. This is how you find n factorial. So 2 factorial means 1 into 2. 3 factorial means 1 into 2 into 3, like that. So got everything? All it takes is now to substitute. You want my help for that? I hope not, right? But anyways, let us get doing here. Okay, so we know n is 10. What is r here? R is 0 for us. Probability of x equal to r, we say, right? So probability of x equal to 0 means r is 0. So how do we find the first one? The first no defective probability of x equal to 0 is 10C0 p raised to 0 q raised to 10 minus 0. That means what? 10C0 p raised to any number raised to 0 is 1, and q raised to 10 minus 0 is 10 itself. What is 10 factorial divided by 0 factorial into 10 minus 0 factorial? 0 factorial is 1. So 10 factorial divided by 10 factorial, it is 1. So 10C0 becomes 1. So basically it is q raised to 10. What is q? Q is 0.85. So 0.85 raised to 10 is probability that there are no defective fuses. Now, so I am not doing the calculation. Okay, you do the calculation and tell me what answer you got. Okay, it's just a matter of now clicking your calculators and finding out. Now, the next thing, at least one is defective. So I said earlier also, at least one is defective means there is one or more defective. So probability of x equal to 1, x equal to 2, x up to x equal to 10, or add it all up together, or easier way is 1 minus nothing is defective. That is 1 minus x equal to 0. You already got probability that x equal to 0. So 1 minus that answer, you will get at least one defective. Easy. Easy enough, right? Simple alle idokke. Tatra valiya paadonnulla. It is not a very big deal. Okay. So that is it. Easy question. Don't have to worry about this numerical question. If this comes in your exam, I'm sure you will be able to figure out and do it properly. Right? I hope so. So, in quality control, this kind of calculation, once again, I'm repeating because this is a very, very important type of problem, not just for your term and examination or assignment, but also for your future. This kind of decisions or this kind of calculation, it decides inspection policies. If the probability of at least one defective in a small sample of say 10 is over maybe 50-60%, then it tells the company that defects are too frequent and more rigorous checks or process improvements will be needed. Otherwise, we are going to make a lot of money. We are going to lose a lot of money in servicing claims. Think of it like buying a box of 10 light bulbs, and when you know that 15% of all the bulbs are bad, then there is a good chance, like about 70-71% chance, that at least one is not going to work in that box when you get home. Okay, so it is very important to know how such problems can be calculated as a manager. Okay, so if this question appears or such a question, such a form of question appears in your term and examination, always remember to first state your binomial formula clearly. Then identify your P, Q, N and R from the question. Calculate P is equal to R using the formula of binomial distribution, and if it is like this, like no defective and at least one defective, then it is easy. We can simply use the complement rule if it is possible. Or say, for example, if it was like at least two defective, then you can't use this complement formula. You will have to calculate P is equal to X equal to 1 plus P is equal P of X equal to 2 and sum it up and write. Okay. So depending on that, you use the formula and present the probabilities both as decimal and as percentage form. So, like for example, if this P is equal to P of X equal to 0, 0.85 raised to 10, you would have got some X value, right? So, that is probability that no defective is X percentage, that means. Okay. Uh, so like that you can, what you can say, tell. So both in decimal as well as percentage form, you write your answer, and there is no way that if say you have written the formula, even if there is some small calculation mistake at the last step, you will at least get the marks for the steps till then. Okay, so don't skip calculation. Show like this all each and every step by step calculation. I know it's a bit, irritating to show it, but still show it, because even if your last answer goes wrong, you will get marks for the steps. Okay.